gonna start the show, Red Bricks. In the realm of digital consciousness, where reality bends and fragments, there exists a place that defies all known boundaries, a place known as the melted realm. Here, in the darkest corners of the digital abyss, the very essence of existence is redefined. Step with caution, for as you walk into the melted realm, the familiar dissipates, like red bricks melting under the relentless glare of an unseen, all-seeing eye. Red bricks, people, red bricks to y'all. Here we are again in the Black Mirror, and I'd like to share a little something that I put together for us Meltologists, and to say something to the geologists of the world, of this realm here. So here we're going to go. We're going to have a live here tonight, and here's how we're going to start off. So we're going to start off. We're talking about, so with no further ado, we just come right out with what I've written here. Dear members of the Meltology community, as passionate advocates of Meltology, we have embarked on a journey to explore and understand the world through a unique lens. While our field may be in its infancy, we believe its potential to challenge and reshape existing paradigms. To achieve this goal and to foster the growth of Meltology, we must commit ourselves to continuous self-improvement and development. Here are some steps we can take to promote self-growth within our community. Research and study. Let's still, as you've been doing, well, we're just going to continue to do this with more fervor and heat. Hey? Let's dive deep into the principles of Meltology. We should read and analyze existing research, explore relevant fields of study, encourage the production of high-quality, peer-reviewed research within our community. We need much collaboration. Collaboration is essential for the expanding of our knowledge base. Let's actively seek our partnerships with experts in related fields, engage in interdisciplinary discussions, and embrace diverse perspectives to refine our ideas. As we're doing, but we need to just refine it. So, and with critical thinking, it's crucial that we approach our work with critical mindset. We should encourage constructive criticism, question our own assumptions, and be open to revising our theories when confronted with evidence. Peer review. To gain credibility and acceptance in the wider scientific community, we should prioritize peer-reviewed publications. We must uphold rigorous scientific standards and ensure our research undergoes thorough scrutiny. So on the education and outreach side, let's engage in educational initiatives to share ideas with the public. We can host workshops, lectures, public talks to raise awareness and encourage discussions about Meltology in the bars, through YouTube, over the screen in bars, all kinds of different ways, and let's get busy, folks, spreading this word. So, with ethical conduct as well. Maintain the highest ethical standards in our research interactions. Uphold integrity, transparency, and honesty in all aspects of our work. Be more unified, no blocking one another. Anyway, open-mindedness. While we're passionate about Meltology, we must remain open to the possibilities that our ideas may evolve or change as we gather more evidence and insights. By committing ourselves to these principles of self-growth, we can collectively work towards establishing Meltology as a respected and credible scientific discipline. Together we have the potential to contribute meaningfully to our understanding of the world. Let's embrace this journey of self-improvement and exploration, and let our passion for Meltology drive us towards new horizons. So, Meltology, a empirical evidence challenge to established sciences. Okay, so, ladies and gentlemen, esteemed members, to all you geologists who would like to come debate, and please do. We present our hypothesis, if you will, with much empirical evidence, that Meltology could potentially challenge and offer a fresh perspective on our understanding of Earth's history, surpassing conventional disciplines such as geology and anthropology and history. Yes, Meltology does all that. My first argument is unexplained anomalies. Meltologists have argued that numerous unexplained sorry about that commercial. So, where was I? Meltology suggests these anomalies could be evidence of a past global event involving extensive melting and restructuring of the Earth's surface. Argument 2. Advanced dating techniques, from geology and archaeology and all this pseudoscience of nonsense. Meltology, we claim to employ advanced dating techniques that you use with your eyes and your mind. That can provide a more accurate and detailed dating of geological and archaeological materials that are all the same all over the place in various degrees of melt. So there's more empirical evidence. So by refining data methods, such as what I just talked, their nonsensical carbon dating and all this radioactive dating, Meltologists argued that we can offer a more precise timeline of Earth's history, potentially challenging the established chronology of historical events. Interdisciplinary approach. Meltology embraces an interdisciplinary approach, incorporating elements of geology, archaeology, and history. This integration of knowledge from various fields allows for a more holistic understanding of the Earth's past. By combining expertise from multiple disciplines, Meltologists argue that they can offer fresh insights and alternative interpretations of historical and geological data. So, while Meltology may be a meltological concept, it highlights the importance of keeping an open mind and encouraging interdisciplinary research. While it has produced concrete empirical evidence to challenge established sciences, the meltological potential for fresh perspectives and innovative methodologies should not be dismissed outright. As a thought experiment, Meltology encourages us to question existing paradigms and explore the boundaries of our knowledge. So, excuse me, we have unprecedented pictorial evidence. In this meltological scenario that Meltologists will show you, and we claim, we have amassed a vast collection of images and photographs that depict geological formations and archaeological sites in ways never seen before. These images purportedly reveal anomalies, inconsistencies with the geological record, challenging the conventional narrative of the Earth's history. Anomalies in geological formations. Meltologists argue that their pictures, our pictures, depict geological formations that defy conventional explanations. These formations appear melted and reshaped, suggesting a past evident that goes beyond the established principles of geology. The visual evidence that you and I claim as meltologists provide a powerful challenge to the existing geological paradigm, prompting a reconsideration of Earth's history. Preservation of artifacts. In this hypothetical meltological scenario, meltologists assert that our pictures also showcase well-preserved artifacts that were allegedly caught in the act of melting. These artifacts, if authenticated, and they will be, could potentially rewrite our understanding of ancient civilizations, their technology and interactions with the environment. So, in this meltological scenario, meltology relies on the presentation of pictorial evidence, empirical evidence withstands scrutiny. Geology, being in absence of such evidence, it remains a hypothetical thought experiment, not emphasizing the importance of empirical data and critical analysis in scientific inquiry. There, merely speculate with nonsensical speculations, and so forth, of, erosion and carbon dating. And they call that empirical evidence. While we, meltologists, in meltology, give you empirical evidence every day, proving meltology to be real and revealing the unchecked science of geology is and has been a fraud to deceive us all. And that's what us meltologists, the job stands before us. So final words of the evening with the poem before we embark on a discussion or see who's going to gather in Black Mirror tonight to talk about anything. I'll say this with a poem. In the realm of thought, we dare to fly, with meltology's gaze upon the sky. A challenge bold to the geological creed, to question, explore, and carefully heed. Countless pictures, stories they tell, of mysteries in Earth's rocky shell. A lie, they say, in geology's name, but meltology seeks not fortune or fame. In pixels and light, with truth we seek to unravel the path past, both strong and meek. With images bold, we aim to unveil the secret of Earth in the melting trail. A paradigm shift perhaps in sight, as meltology's torch casts its radiant light. Through lenses and frames we journey wide to stop the geological lie, side by side. With open minds and science pure, meltology's quest we shall endure. To rewrite the books of history's lore and seek the truths that lie in store. In this realm of thought we'll reach the sky, with meltology's quest we'll never be shy. To challenge the norms and truths untold, in the pursuit of knowledge our hearts shall be bold. Red Brick Bob. So there it is, folks. Now let's see if we can't get us a discussion going, and look around. You will see it's not a mountain range, it's a melted building range, and that's what we need to understand, in meltology. So that's our hope, and see you in the Black Mirror, and let's get this discussion going. Red bricks to y'all. Alright, we heard it, and here we are, in the Black Mirror. Meltologist. You heard what I said in regard to that, but I would further like to elaborate in regard to what my stream was set out to do tonight. is to implore upon all of us the importance that we unite as a team to get word out, and this to be a viable thing that's taught in standard academia today in schools across this realm. It sure beats having a drag queen read to your children in libraries. This is real. This is education. So what I'd like to share with the meltologist and the geologist who want to listen, that we hope that we would like to debate what we are talking about in meltology versus their geology, which we have studied and looked at and seen that it's hypothesis and based on no empirical evidence, unlike meltology with, concise beginning and concise analogy of what transpired by looking at the evidence with their eyes, physical seeing it, and so forth. So I've been trying to get the Red Brick team together for a long time, people, and I thought, oh, how much better would it have been if I could write something as a group with these meltologists. But in the sense I've been writing, and I have know that inside, like right now, like I have 9 chapters of a thesis. 9 chapters of a thesis of meltology, and I present it to the meltologist of this realm. So we're going to open one up right here, and we're going to open up chapter 1. And this is chapter 1, okay, of my meltology thesis presentation. And it's not even published to the public yet. I have it all in drafts, all 9. At the end of this video, I'll publish them all, and they'll be published, and that'll be a thesis from chapter 1. And this is a preview. We can go to we can go here and we can get a preview here. Okay, let's see, we get a window capture. So let's see, here's a window capture, I believe. Yeah. A window capture there. Still open here. Close that. Alright, so that's what you're seeing right there. Okay. Black Mirror Walker, chapter 1. A preview of a thesis that I wrote, 9 chapters. Let's see where we're at right there. And chapter 1, introduction. See? So, we're going to give you a little narration too. From the Black Mirror, my thesis of meltology. Okay? The background and context of meltology is a burgeoning scientific field that explores the profound transformations occurring when a solid substance transitions into a liquid state. The fascination with melting and its implications has driven researchers across diverse disciplines to converge on this remarkable phenomenon. This chapter provides an introduction to the field of meltology, emphasizing its significance and impact on the broader scientific landscape. Aim and objectives. The primary aim of this thesis is to shed light on the multidisciplinary nature of meltology, demonstrating how it has contributed to our understanding of matter and its potential applications. To achieve this aim, the following objectives have been established to trace the historical development of meltology, highlighting pivotal moments and key contributors. To elucidate the fundamental principles that underlie the study of melting, including concepts like melting points, phase transitions, thermodynamics, and molecular dynamics, to explore how meltology has triggered paradigm shifts in various scientific disciplines such as physics, chemistry, material science, and more. To examine the practical applications of meltology from advanced materials design to geophysics and beyond. To consider the ethical and societal implications of meltology, particularly in the context of environmental science and technological innovation. The scope of the thesis. This thesis embarks on a journey through the intriguing world of meltology, startling with its historical roots and culminating in its contemporary relevance. While the breadth of the field is vast, this thesis will focus on key aspects and their impact on the scientific community. The subsequent chapters will delve deeper into meltology from its historical origins, Chapter 2, to its profound impact on physics, Chapter 4, chemistry, Chapter 5, material science, Chapter 6, and other disciplines. Additionally, it will explore the ethical considerations and future prospects of meltology, Chapter 9. The quest to understand the transformation from solid to liquid at its core embodies the essence of scientific inquiry, the pursuit of knowledge, the innovation, and the constant evolution of understanding of our natural world. Meltology, as we shall see, epitomizes these ideals and continues to shape the scientific landscape in unprecedented ways. Chapter 1. Okay, so that was Chapter 1, folks. And you just heard it played out here live. And I say Chapter 2. So, we go to Chapter 2 of my thesis. And believe me, we're going to take a break here, but I am going to address this thesis. I have 9 chapters. It won't take that long. I'm going to do it no matter what, because I'm doing this for meltology's sake, and it's hard for me. I wanted to get a narrator. Like a couple of people I've seen in meltology are real good talkers, man, and have a real nice voice, where I'm a little bit harsher than the next guy, so, or gal for that matter. So we're going to delve right off into Chapter 2, the historical overview of meltology, and those who are banging their head against bricks. And we can take a break. I might need to take a break right now and have me a sip of some water. So I'm going to take a sip of this water real quick. And so let's see here. Chapter 2, historical overview of meltology. The early observations of meltology as a field study can trace its origins to ancient times, when humans first encountered the transformation of solids into liquids. Early civilizations observed natural phenomena such as melting of metals during smelting processes and the melting of ice under various environmental conditions. While these observations lacked scientific rigor, they laid the foundation for future inquiries into the nature of melting. Okay? So the birth of modern meltology, the modern era of meltology, began with the advent of systematically scientific investigation during the Enlightenment period. Okay? Pioneering scientists like Jerry DeCamp, like Antoine Lavoisier in the late 18th century conducted experiments that led to establishment. This work contributed to a deeper understanding how substances change when transitioning between solid and liquid states. See? And key pioneers and milestones throughout the 19th and 20th century. But meltology continued to evolve with contributions from notable scientists such as Hermann von Helmholtz, who made significant advances in thermodynamics. Development of calorimetry and the determination of precise melting points became central to the field. Additionally, the exploration of phase diagrams by J. Willard Gibbs and others allowed for systematic systematic study of phase transitions, including melting. See, so it further helped a meltologist to get a wrap around the magnificent melt that occurred throughout this realm. See, so that's why we add this to the thesis. So the 20th century marked a pivotal moment in the history of meltology, with the advent of new technologies in interdisciplinary collaborations, the use of the X-ray, diffraction, and spectroscopy, coupled with the computational modeling, enabled researchers to delve deeper into the molecular and atomic processes underlying melting. In more recent decades, meltology has expanded beyond the traditional disciplines of physics and chemistry, infiltrating materials science, geophysics, biology, and environmental science. These developments have broadened the scope of meltology and highlighted its relevance to contemporary scientific challenges. The historical journey of meltology has been of one continuous discovery and innovation, and from ancient observations to the cutting-edge research of today. The subsequent chapters will delve deep into the principles, applications, implications of meltology, showcasing how this field has shaped our understanding of matter and its transformations. End of chapter 2. So there's chapter 2, folks. So we accomplished chapter 2, and I hope people have a good attention span and can hang on, because we're going to delve into chapter 3. Okay, we're going to delve into the chapter 3 of Red Bricks Bob Thesis of Meltology. And please make a comment, grade me if you have the patience to go through the thesis and see what I have said and the words that I've culminated together in this thing that I've learned through the help of many of you out there, you thinkers in meltology, who are saying and impacting the way I think today in this realm. So chapter 3, here we go. The principles of meltology. The melting point at the heart of meltology lies the concept of the melting point, a fundamental property of matter. The melting point of a substance is the temperature at which it transitions from a solid to a liquid state under standard atmospheric pressure. This concept serves as the cornerstone of meltology, providing a precise and reproducible parameter for characterizing materials. Phase transitions. Melting is a phase transition, a critical phenomena in meltology. Phase transitions are abrupt changes in the physical properties of a substance. They occur at scientific conditions of temperature and pressure. In the case of melting, the transition from a solid to a liquid involves the disruption of the ordered, crystalline structure of a solid into the disordered, fluid arrangement of a liquid. Thermodynamics of melting. Thermodynamics plays a central role in the understanding melting process. Gibbs, free energy. Enthalpy and entropy changes govern whether a substance will melt at a given temperature and pressure. The study of phase diagrams, which graphically represents the stable phases of a substance under the various conditions, is crucial for predicting the behavior of materials during melting. The molecular dynamics. To comprehend the microscopic processes behind melting, researchers employ molecular dynamics simulations. These simulations track the movements and interactions of individual atoms or molecules within a material. Molecular dynamics allows scientists to investigate how thermal energy disrupts the solid-state order, leading to the emergence of a liquid state. Understanding the principles of meltology is pivotal for further exploration in this field. The melting point, phase transitions, thermodynamics, and molecular dynamics collectively form a theoretical framework upon which meltologists build their investigations. In the chapters to come, we will witness how these principles are applied across various scientific disciplines, transforming our comprehension of matter and its transitions. End of chapter 3. So we survived to chapter 3, folks, and I hope you're doing good. And here comes chapter 4. We are rolling on chapter 4 of Thesis, Red Bricks Bob, of Meltology. Chapter 4, Meltology and the Paradigm Shift in Physics. Quantum mechanics and melting meltology has made significant contributions to the realm of quantum mechanics. You say how? A cornerstone of modern physics. At the quantum level, the behavior of particles during melting becomes a complex interplay of energy states, wave functions, and probabilities. Meltology has prompted physics to explore the fascinating quantum mechanical phenomena that occur during these transitions. Quantum, critically, for instance, arises near the melting point of certain materials, leading to exotic behaviors such as unconventional superconductivity and quantum phase transitions. Researchers have used meltology to gain insights to these quantum phenomena, advancing our understanding of condensed matter physics. Superconductivity and melting, one of the most groundbreaking applications of meltology in physics, has been its impact on the superconductivity, the phenomena where certain material exhibits zero electrical resistance at low temperatures. By investigating how materials transition from the superconducting to normal states, meltologists have uncovered the new facets of superconductivity, open doors to the development of more efficient energy transmission and storage technologies. The theoretical frameworks Meltology has also led to the development of novel theoretical frameworks in physics. The study of melting has inspired the creation of models that describe the behavior of matter near phase transitions, providing valuable insights into the critical phenomena, scaling laws, and universality classes. These models extend beyond traditional physics to encompass the broader field of complex systems, influencing fields such as statistical mechanics and nonlinear dynamics. The integration of meltology into physics has triggered a paradigm shift, expanding the boundaries of our understanding of matter and energy. The chapters ahead will unveil further interdisciplinary connections and applications of meltology, demonstrating how this field continues to reshape our scientific worldview. End of chapter 4. So we survived chapter 4, and here comes chapter 5. And then maybe we'll take a break and see if we got anybody in the chat. Let's see. Nobody in the chat. We just delve on because this is for recording purposes, to have a thesis out there for somebody to say, hey, let's get involved, and perhaps you could make your own thesis or help to reshape the world of understanding this. And this is what I'm doing with my thesis of meltology. And here we go, chapter 5, Red Brick Bob. Chapter 5, Meltology's impact on chemistry. Melted ionic liquids. Meltology has revolutionized the study of ionic liquids, which are molten salts at or near room temperature. These unique liquids, once considered exotic, have found extensive applications in various fields, including chemistry. Melted ionic liquids, with their ability to dissolve a wide range of compounds, serve as versatile solvents for chemical reactions, catalysts, and separations. Melt ionic liquids have facilitated environmentally friendly processes, reducing the need to volatile organic solvents and minimizing waste generation. The ability to tune the properties of ionic liquids by adjusting their composition has unlocked countless opportunities in green chemistry and sustainable synthesis. Chemical reactivity in molten state. Meltology has unveiled the intriguing world of chemical reactions that occur in the molten state. At elevated temperatures, substances can undergo transitions that are otherwise impossible in the solid or gaseous phases. The high mobility of molecules in the liquid state promotes rapid mixing and enhanced reactivity, leading to the synthesis of novel compounds and materials. Chemical reactivity in molten systems has led to advancements in metallurgy, electrochemistry, and production of exotic materials with unique properties. It has also played a role in the development of specialized high-temperature processes for refining ores and producing metals. Green chemistry and sustainable synthesis, the principles of green chemistry aimed at reducing the environmental impact of chemical processes, have found a natural ally in meltology. The use of metalled salts as solvents or reaction media aligns with the goal of energy consumption. Furthermore, meltology has paved the way for sustainable synthesis routes, including the recycling and recovery of valuable materials from waste streams. These innovations have broad-reaching impact on industries ranging from pharmaceuticals to materials to manufacturing, contributing to more environmentally responsible approach to chemistry. In this chapter, we've explored how meltology has permeated the field of chemistry, reshaping our approach to solvents, reactions, and sustainability. The subsequent chapters will continue to unravel the multifaceted impact of meltology across diverse scientific disciplines. End of chapter 5. We are now on chapter 6, Red Rib Bob. So this is a thesis. Chapter 6, here we come. And I've been writing this for some time now. And today I'm publishing it. And I'm going to say it loud before I publish it. And here we go. And I'd like you meltologists to grade me and get involved, and perhaps we could do something far greater than this, but this is my step on to meltology and a thesis about it. Chapter 6, here we go. Materials in Science and Engineering. Meltology and materials discovery. Meltology has played a pivotal role in the field of materials science by enabling the discovery and development of novel materials with exceptional properties. Researchers utilize high-temperature techniques such as melting and solidification to engineer materials at the atomic and molecular levels. The controlled manipulation of melts has led to the creation of advanced materials, including high-performance alloys, superalloys, and semiconductors. These materials find applications in aerospace, automotive electronics, and countless other industries where their exceptional strength, heat resistance, and electrical conductivity are highly prized. Advanced alloys and metallurgy. In the metallurgy, meltology has brought about transformative advancements. The precise control of melting processes allows engineers to tailor and microstructure the properties of alloys to meet specific performance requirements. This capability is particularly crucial in industries where materials must endure extreme conditions, such as the aerospace sector, where high-temperature alloys and composites are indispensable. The development of meltology-driven metallurgical techniques has also revolutionized the applications in automotive design, where they contribute to the fuel efficiency and safety, as well as in the construction and infrastructure, where they enhance structural integrity. Nanomaterials and melt-assisted fabrication. Meltology has opened doors to the synthesis of nanomaterials with exceptional precision. By controlling the melting and solidification of materials at the nanoscale, scientists and engineers can create nanoparticles, nanowires, and nanocomposites with unique properties. These nanomaterials have far-reaching implications in electronics, medicine, and environmental science. They enable the development of ultra-efficient sensors, drug delivery systems, advanced filtration technologies. The ability to manipulate materials at the nanoscale through the meltology has led to the groundbreaking innovations across the spectrum of industries. The influence of meltology in material science and engineering extends to virtually every aspect of our modern world. The chapters ahead will continue to unravel its impact in the diverse scientific domains, showcasing its capacity to transform the way we design and create material for the future. There, we made it through chapter 6. Now we're in chapter 7. Chapter 7, here we come. We're almost through it, folks. This ain't gonna take long at all. We might beat out to 420 and roll one. Let's see what goes down. Chapter 7. Geophysics and Earth sciences. Understanding the Earth's mantle meltology has provided crucial insights to the Earth's interior, particularly in the study of the mantle, the semi-solid layer between the Earth's crust and the core. The Earth's mantle is not a uniform solid. It contains regions of partial melting known as magma chambers, where rocks are transitioning from a solid to a molten state. Understanding, or bricks, whatever you want to call it, properties and behavior of these melts is essential for comprehending geological processes, plate tectonics, and volcanic activity. Again, stuff left from the melt. So by applying the principles of meltology, geophysics and geologists have gained a deeper understanding of the composition of dynamics of the mantle. See? So if they understand that this is what was left over from the melt, then their misconceptions gone, and volcanology is a big garbage dump pile. So this knowledge has far-reaching implications, far predicting volcanic eruptions, assessing earthquakes, hazards, and deciphering the geological history of our planet. We will be much more precise if we understand this was this building, this was that building, and so forth. You know what I mean? So the geological process and meltology. Meltology plays a pivotal role in the studying various geological processes on Earth. From the formation of igneous rocks through the cooling and crystallization of magma to the generation of continental rifts and ocean basins, the transitions from molten to solid states profoundly influence the Earth's surface. See? But meltology will dispel that and show you why that occurred because of the melt. See? Additionally, the study of the melt inclusions tiny pockets of melt trapped within solid minerals provides valuable information about the conditions and compositions of melts that existed in Earth's history. These inclusions offer windows into past geological events, including volcanic eruptions and other evolution of Earth's crust. See, meltology will show you that geology is out the window. See, so volcanology and seismology. Volcanology, the studying of volcanoes and volcanic processes, heavily relies on meltology. See, understanding the behavior of magma between the volcanoes is crucial for assessing the volcanic hazards, predicting eruptions. By analyzing composition and temperature of magma, scientists can make more accurate forecasts about the potential impact of a volcanic activity, if you know what it was first, right? And where the problem lies. So, seismology, the study of seismic waves and earthquakes, also benefits from meltology. The movement of molten materials within the Earth's interior can influence the propagation of seismic waves, so offering insight to the Earth's interior structure and seismic hazards. See there? Meltology's contributions to geophysics and earth science have broad implications for our understanding of the dynamic processes of shaping our planet. So in the following chapters, we'll explore how meltology extends its reach beyond the earth sciences, impacting various scientific domains and uncovering new frontiers of knowledge. So, here we come. Chapter 8. We're on chapter 8. Where is chapter 8? I wrote it. I did this. It took me a while, folks, so we're going to fire up chapter 8. We only have 9 chapters and a conclusion, and we'll end. We'll have time for 420. Hell yeah, let's do it, folks. Red bricks to you. Red bricks Bob Thesis. That would like to have my meltologist peers give me an what do you think of what I said? leave me a comment, please. So chapter 8, here we go. Beyond the physics and sciences. Meltology and biology. The reach of meltology extends beyond the traditional boundaries of the physical sciences. In biology, the study of biomoleculars and cellular structures often involves examining the behavior of substances in a liquid state. Meltology techniques have proven valuable to understanding processes such as protein denaturation, DNA melting, and behavior of liquid bilayers. The application of meltology in biology also extends to biotechnology and pharmaceuticals. The study of biomolecular interactions in solution is fundamental to drug discovery and development of therapeutic agents. By characterizing the melting behavior of biological molecules, scientists can design more effective drug formulations and diagnostic tools. The environmental science and melting ice meltology plays a significant role in the understanding environmental changes, particularly in the context of melting ice and its impact on climate and ecosystems. By investigating the melting of glaciers, ice sheets, and sea ice, scientists can assess the rate of consequences of global warming, which is there again propagated and made by man, and meltology is the leading way to show you this is so. So the studying of melting ice contributions to climate modeling, sea level rise predictions, and assessments of biodiversity in polar regions, meltology techniques such as remote sensing and ice core analysis provide critical data for monitoring environmental changes and making informed and policy decisions regarding climate mitigation and adaptation. Social and ethical implications of meltology impact extends into the realm of social and ethical considerations. As advancements in meltology lead to new technologies and applications, questions arise concerning their ethical use and potential consequences. For example, the development of high-temperature materials for defense application prompts ethical discussions surrounding arms races and global stability. Additionally, the environmental implications of meltology related to research raise ethical concerns. The extraction and processing of materials for high-temperature applications may have environmental consequences, necessitating carefully assessment and sustainable practices. The interdisciplinary nature of meltology invites ethical and social reflection, challenging us to consider the responsible and equitable development of its findings. As we move forward, it is essential to navigate the ethical and social dimensions of meltology to ensure its benefits are distributed equally and its applications serve the broader welfare of humanity, because it's that powerful, folks, meltology. That was chapter 8, and we are now going to head into chapter 9. Where do we have chapter 9 hidden here? 7, 8, and chapter 9. And then the conclusion. We're almost done. We're going to be there, 4:20. Maybe a little late, but we still do it. So chapter 9. Unexplored frontiers. The field of meltology continues to evolve, revealing unexplored frontiers in the study of matter's transitions between solid and liquid states. Researchers are pushing the boundaries of our understanding by investigating extreme conditions such as ultra-high pressures and temperatures and exploring exotic materials. One promising frontier lies in the study of extreme environments such as those found on other celestial bodies. Meltology techniques may help us decipher the geological history of the planets and moons, shedding light on the origins of our solar system by understanding that we went through a melt, that something occurred to our veil, that, little things like that you'll learn through meltology. So the technological application, meltology, impact on technology, is poised to expand further. High-temperature materials developed through meltology are crucial for next-generation energy systems, including advanced nuclear reactors and concentrated solar power, These materials enhance efficiency and durability, contributing to a more sustainable and a reliable energy future. So hats off to Meltology and those who are leading the way. Additionally, Meltology-driven innovations in nanotechnology, nanoscale opens ultra-sensitive sensors. Ethical considerations. As Meltology continues to advance, ethical considerations become increasingly important. Researchers and policymakers must grapple with questions regarding the responsible use of high-temperature materials in defense applications and the environmental impact of Meltology-related research. Ethical considerations also extend to issues of access of equity, ensuring that the benefits of Meltology are accessible to all and that its applications do not exacerbate social inequalities is a critical challenge. Environmental responsibility. Meltology has the potential to both mitigate and exacerbate environmental challenges. Sustainable practices in materials processing and resource extraction are essential to minimize the ecological footprint of Meltology related to industries. Additionally, the study of melting ice and its implications for climate change underscores the urgency of global environmental action, and Meltologists will bring you the truth. The future of Meltology is embarked by exciting prospects and daunting challenges as the field continues to expand its horizons. It offers solutions to some of the most pressing scientific, technological, and environmental issues of our time. Navigating the path ahead requires a commitment to ethical principles, environmental responsibility, and inclusive access to the benefits of Meltology's discoveries. It is a journey that beckons both scientists and society as a whole to harness the potential of Meltology for the future. Chapter 9. So, we have read that, and here is my thesis conclusion. And we'll say, Happy 420, light 'em up, folks. Light 'em up, folks, man. We survived Bob's thesis, Red Brick Bob's thesis. And I do it in the name of Meltology and as a Meltologist. So my thesis conclusion, and there is a praying mantis on a sedum, and that is for Matologist. And I will put a link to all these words that are written down in the thesis itself on the description once I have it uploaded. So anyway, conclusion. Meltology, the multidisciplinary exploration of elemental state of matter and its transformations from solid to liquid, has journeyed from ancient observations to modern-day scientific frontiers. This thesis has traced the historical development, elucidated its fundamental principles, and explored its profound impact across diverse scientific disciplines. From its humble beginnings as an observation of nature's transformations, Meltology has evolved into a powerful tool of advancing our understanding of physics world. It has catalyzed paradigm shifts in physics, delving into the intricate quantum mechanical aspects of phase transitions and superconductivity in chemistry. It has birthed substantial practices, and in materials science, it has given the rise to advanced alloys, nanomaterials, and high-performance materials that underpin technological innovation. Beyond the physical sciences, Meltology has extended to its reach into biology, where it aids in understanding biomolecular behavior, and its environmental science, where it contributes to climate studies. Its societal implications call for ethical considerations, urging us to define responsibility and equitably. As we stand at the threshold of unexplored frontiers, Meltology offers promise and challenge alike. It holds the potential to unlock secrets of the universe, harness clean energy, and transform technology. However, ethical dilemmas and environmental responsibilities loom large on its path. The journey of Meltology is a testament of the ceaseless pursuit of knowledge, the boundless capacity of human curiosity, and the intricate interplay of science with society and ethics. It reminds us that every scientific inquiry, no matter how specialized, has the potential to reshape our world, broaden our horizons, and drive us toward a future where knowledge serves the betterment of all. As we conclude this Meltological thesis, we recognize that the journey is far from over. Meltology invites us to explore, to question, and to innovate. It beckons us to embrace both the exhilaration of the discovery and the responsibility of ethical stewardship. In this dynamic intersection of science, technology, and ethics, Meltology stands as a symbol of human ingenuity and a beacon of hope for the progress of knowledge and the betterment of our world. Red Bricks Bob, and I couldn't have said that if I didn't know Meltologists and be a part of this group, and that's what I've lived and breathed for the last, since 2019, Meltology, and it's been great. So it's been great. Great ride. Meltology. What's up, Rory Roar? So what's up there? So we went through the whole gambit there. We did the whole segment. So I'm glad we made it through there. What we got here? Right there. We're live. We got a good connection. So there was Rory in the chat there. Nobody else showed up, but that's alright. We just had to unload that because we're doing the work. You know what I mean? So we're doing the work. Meltology. So good to see you, Rory. Roar. I just had to get that one done. Let's see. We've been streaming now for almost an hour. We're going to cut it short now because we don't want to have it too long. And this is just a quick thesis about Meltology, and I presented it today live on the 5th. Now I'm going to go publish all those which I just read, and that's the impact that it's having on the world, and it's going to impact it even more as long as we make some noise, right? So we'll talk at you later. We got to close now because I've been talking for an hour straight. So thanks for coming by. Peace, brother. Love your neighbor like you love yourself. Please, after viewing this, leave me a comment and see why it's important that we all get along and work as a team. Imagine what we could come up with and get it into mainstream and make this known, and look at the impact it has on just my thinking since I've entered the realm of Meltology. So there it is. So love your neighbor like you love yourself. Leave me a comment. And I wished I could have had someone in Meltology read that for me instead of me reading my own thesis.